Hello, this is 9.5 and we're going to solve quadratic equations by completing the square. And this is a new method. I believe page 596. If you have a quadratic in the form of x squared plus bx, okay? So without a c term or without a c term on the same side of the equal side, okay? You can make it into a perfect square by completing the square. In order to complete the square, you need to know the magic number. So you'll hear me say half of b squared, because that's what this is. B divided by 2, and then that number squared. Right? A couple things. This is going to always be positive. Okay? And this is the magic number that you will add to both sides of your equation. These are the steps, so you might want to write these down. So first you write it into this form with just the x squared plus bx on one side, get everything else to the other side. You're going to find the magic number. You're going to take your b, divide it in 2, and then you're going to square it. And then you're going to add it to both sides. Then you'll factor the left side of the equation, and they'll end up being a binomial squared. And that's the whole point, because then you can solve using the square root property. And I'm hoping this will make more sense as we go through and do it. So here is an example. The first step, get that 12 on the other side. So I have x squared minus 6x equals 7. Then I need to find my magic number. So I'm going to take half of b. Well, b is negative 6. So half of that. And then I'm going to square it. So half of negative 6 is negative 3, and negative 3 squared is a positive 9. So I need to add that to both sides. So on the left side, it'll look like this. And on the right side, you are literally just adding 9 to that. So it says 16. Then what you want to do is take a look at your left side. I'm going to rewrite this up here so I have a little bit more room. This x squared minus 6x plus 9, you can factor that into binomials. And when you do that, you're going to see that you can write it as a squared. So that's what you should do. Write x minus 3 squared equals 16. And now you can use the square root property to solve. So you take the square root of both sides. So this is just x minus 3. And this is plus or minus the square root of 16 or plus or minus 4. Now remember, when you add 3 to both sides, you're actually adding 3 to a positive 4 and then adding 3 to a negative 4. So I'll do that up here. So x equals negative 4 plus 3 and x equals positive 4 plus 3. So that's not really a 3. So x equals a negative 1 and a 7. Those are your two answers. Let's try another one. Okay, so again, we need to start with this 3 on the other side. So I have x squared minus 12x equals 5. Okay? And then I need to find half of b and square it. So half of b is negative 6. And squared is going to be 36. So I need to rewrite the left side by adding that 36. And then I need to rewrite the right side by adding that 36 to that 5. Yes, to that 5, so I get 41. Now I'm going to factor my left side of the equation. And it looks like I'm going to have x minus 6 and x minus 6, which means I'm going to rewrite it as x minus 6, that binomial squared equals 41. And then I'm going to take the square root of both sides, which leaves me with just x minus 6 on this side, and a plus or minus the square root of 41 on this side. Remember, I don't want a decimal approximation. I'd rather you leave it like this. And then we're going to add 6 to both sides, which means your answer is going to be 6 plus or minus the square root of 41. So you still have two answers, 6 plus the square root of 41 and 6 minus the square root of 41. And both of those are correct. Another thing to talk about is when the leading coefficient isn't just 1. So in these examples up here, we just had a was just 1, a was just 1. But here a is negative 2. So what we need to do is get a to 1. So in order to do that, we have to divide every term by negative 2. Then we have an x squared minus 4x plus 9. Now I'm going to start my process. Now I'm going to subtract my 9 and get it to the other side. So I have x squared minus 4x equals negative 9. Then I'm going to take half of b and square it. So my b is negative 4, so half of it is negative 2, and squared is 4. So I'm going to add 4 to both sides. I can almost sneak that in here. So now this side looks like x squared minus 4x plus 4, and this side looks like just a negative 5. My left side, I can factor it into, oh, why does it do that? Oh, good gosh. Aha. Okay. So I'm going to factor that. So it's x minus 2 times x minus 2. And I'm going to rewrite it as x minus 2's quantity squared equals negative 5. And I'm going to take the square root of both sides. Now I'm no genius, but if you put the square root of a negative number into your calculator, it's going to give you an error. That is not a real number, which means this is not a solution. So, no solution for this one. Let's try this one here. We need to divide every term by 3. So I'll just, whatever. Okay. I think it's time for me to quit. Okay, so I'm going to divide every single term by 3, which leaves me with x squared minus 3x minus 1 equals 21. Nope. Equals 7. And then I'm going to add 1 to both sides. So I have x squared minus 3x equals 8. And then I'm going to use the magic number, which is half of b squared. Now, I like to use fractions. So half of b is 2, or half of b is negative 3 over 2, and squared is going to give me 9 over 4. If you add those to both sides, x squared minus 3x plus 9 over 4 equals, And 8 plus 9 over 4, it's going to be, well, 10 and a quarter. So I'll write that. Okay. You can still put this into binomials. Okay? There's a secret about that. The secret is that the number that goes right here, that number is just half of b. So that number is always just going to be half of b. Well, half of b was negative 3 over 2. And that's exactly what this will be. So I'm going to rewrite this then as x minus 3 over 2 squared equals, and I think I'm going to rewrite this as 41 over 4. I'm going to take the square root of both sides. This becomes x minus 3 over 2. This, I'm going to write, oh, I forgot the plus or minus sign. This is going to be 40 plus or minus the square root of 41. But on bottom, I can just put a plus or minus 2. Okay. I'll bring this plus or minus out front. When I add 3 over 2, I can rewrite this. I'm kind of running out of room. I will grab a different color. I can rewrite this, which is my answer, as 3 over 2 plus or minus the square root of 41 over 2. Now this is totally correct. And another way to write it, because they both have the same denominator, you could write it all where they're both over 2, like this. Okay? So both of those are appropriate, and this one's tricky. I don't think I have anything this crazy in your assignment, but it does not hurt to look at it and see how it's supposed to be done. So I'm going to move on a little bit. Here we're going to write functions in vertex form. And it's the same steps up until through number 4. These are the exact same steps, except that you don't start to solve it. Okay? So it's actually kind of easier. So this is just taking a function that's in standard form, like ax squared plus bx plus c, and we're going to write it in vertex form. Okay? And I would say I don't use completing the square that much to actually solve problems, but I do use it to rewrite functions into vertex form. I do use it a lot for that. So let's go ahead and see. I only have 2 examples because I think you'll catch on pretty quick to this. So just so you know, this y you're going to replace with 0. Okay, so 0 equals x squared plus 2x plus 4. We want to subtract 4. Since we're used to having the 4 on the right side of the equal sign and this stuff on the left side of the equal sign, when I subtract 4, I'm going to actually rewrite it. And that's just for simplicity. So I'm going to rewrite it with x squared plus 2x on the left side and negative 4 on the right side. So all I have to do now, so what I did was I wrote it into this form. Okay? Now I'm going to find the magic number and I'm going to add it to both sides. So half of 2 is 1 and 1 squared is 1. So I'm going to add 1 to both sides. X squared plus 2x plus 1 equals negative 3. I'm going to factor this into a square binomial. So it's x plus 1 times x plus 1. which I'm going to write as x plus 1 squared equals negative 3. Okay, this is where we would normally start to solve. But look at number 5. Do not solve. Set equal to 0 and then replace that 0 back with your y or your f of x. So that means I'm going to add 3 to both sides, which means I'm going to have x plus 1 quantity squared plus 3 equals 0, but I'm just going to write a y. There we go. Vertex form it is. And it doesn't matter if you put the y on whichever side you want. I will do this one next. So same sort of thing. I'm going to subtract 36. But I'm going to rewrite it. So my 36 is on the right. So x squared plus 18x equals a negative 36. Yikes. Okay. I'm going to find half of b squared and add it to both sides. So half of b is 9, and 9 squared is 81. So I'm going to have x squared plus 18x plus 81, and I'm just going to go 81, 45. It's getting late, and I don't trust my math. Okay, this I'm going to write as x plus 9 times x plus 9. So I'm going to write it as x plus 9 squared equals 45. And then I just need to subtract my 45. So I have x plus 9 minus quantity squared minus 45 equals 0, which I will just replace with a y. Vertex form. Remember, the nice thing about vertex form is that you can easily see where the vertex is. This would be negative 1, positive 3. And this one would be negative 9, negative 45. All right, let me know if you have any difficulty with this lesson.